Thank you, everybody, for coming. It is great to be able to share these tools and some of my knowledge with you today. Let's go through some of the disclaimers here. So we all know that everybody is talking about machine learning. Machine learning this, machine learning that. And we know that it is becoming increasingly important to have it within your environment and within your applications. So I'm going to talk today about how to more easily transfer your production, your data scientists' development environment over to a production environment to help you deal with the rise of machine learning. A lot of people joke that machine learning is going to eat all software, which we know isn't going to happen, but it's going to be a new software 2.0, where all the old software needs to integrate with the machine learning. We know that machine learning is vitally important, but we also have other tools or other aspects that can be used in real-time streaming. And in this case, you don't need to build a ML model in a lot of cases. Sometimes you just need to do some statistical analysis on the data as it comes in, and that is as valid as full machine learning. Especially for things like dashboarding and stuff like that. So bringing machine learning from your data scientists environment to your developers environment, we end up seeing that there's a lot of problems because a lot of the time, the data scientist wants to just throw the model over the fence for the developer to implement in their environment, and there's little communication between the two. Or if they work a little more closely together, you can still have problems as well because they use different toolings, model transferability creates extra problems. The developer has to reproduce the data preparations and the post processing. Communication of needs is different, and even their success metrics are different. We're looking at trying to facilitate the data preparation issue. Primarily that you have a data scientist who's built a model with her Jupyter notebook. The the developer says, okay, everything's in Go. The data scientist said, it shouldn't be hard to modify. I don't need to read this all to you. But basically, in the end, the data scientist ends up using gibberish, data science gibberish, to tell the engineer what she's doing, and complete confusion. And it's because the data scientist and the developer go through related but different pipelines. The data scientist often loads the data in mass to a distributed process where they clean and train the data, and then they publish and extract the model for the developer. While the developer is getting the data from individual events, be it a REST call or a Lambda invocation, before they also have to do data pre-processing, evaluate the model, and then respond. So there is a key difference in being able to transform the data. So having the distributed process come over to the developer's pre-processing, you need to have some sort of tooling in between. Because, as everyone has said, 80% of data science is data cleaning. And when you deploy it to real-time apps, most of this has to be replicated, often in its own code or trying to find libraries that act the same way as your Python or R libraries. And this becomes even more complicated because they do have different starting data. And there aren't a lot of tools out there for pre and post processing of data. So we're hoping to introduce a data cleaning box, very similar to how TensorFlow and others have created an ML box, where it is just a matter of plugging in a model or a JSON file to do what you need. And that's where we introduce Catalyst ML. It's an open source tool that has 85 mathematical transformations in fields ranging all the way from natural language processing and computer vision all to basic math operations and data manipulation, such as joins and stuff like that. And it is set up to be language agnostic. So this is a specific a specification that is defined and is posted on GitHub that is intended to be implemented in every language under the sun. Currently, the tool to build it is in Python, and the implementation that runs it is in Flogo/Go. And since the implementation is embedded in TIBCO's open source tool for event processing, you're able to embed your models and your data processing into your apps, such that you can have a one-to-one mapping from the output of your transform into the models. So I'm going to do a demo here for you. So what I am going to do is walk you through the Jupyter notebook that takes data and cleans it in Python. However, at each step of the way, I will add, create a CML artifact that we can run within Flogo. So the repo that has this Jupyter notebook, which I will present later, and this is all discussed in a Medium article as well. This is the CML Maker library. It is in the root directory of that Git repo. So here I'm loading in the data, which is a quasi-simulated credit card data, where V1 through V4 are variables taken from the Kaggle data, credit card data set. And then the fraud label is associated with those. And then I artificially generated the rest of these values. So before we get started actually transforming the data, we need to create the structure that CML will be using and exporting. In this case, we're calling it a financial structure, cleaning some financial data, and I'm arbitrarily setting it as version 1.0.1, but of course it can be anything that is needed. I'm also updating the create date. And I print out the structure and you see all the metadata we just listed. And then it also has space for the input that we're going to be bringing in, the structure that contains all the transformations for that data, and then we're going to define our output. So in this case, I am defining an array of named inputs as our input, as shown here. And so in this case, there's going to be an array of data that contains a map inside of it, so that we can then take the maps and stack them together into effectively a data frame. So the first step we need to do is to add the operation to CML that does that concatenating. So using the add operation method to your CS object, and taking the object that is the operation, you can input it into, you can add it to your structure. And then we can print, then we can print it out, and we see that now we also have concat listed here. And I went ahead and ran a bunch of it, so there's more structures there. Now we can do this for a lot of the columns. So if we look up at our we need to convert these features into something that can be used by a machine learning model. Because as you can see, there's strings here, there's categories, and then there's unbalanced, unnormalized data. So what we're going to do is convert this into a normalized data set. And we're going to do that by normalizing age between 18 and 100, and then normalizing amount, I forget what the normalization amount is, and then we do one hot encoding of the categorical features, and then I actually still have to normalize these the data from Kaggle, because it ranges from -5 to 5. So for our first step, we are going to normalize both age and amount. So I define my age min and my age max, and then I transform the data using pandas, but I need to add that same thing to this. I'm sorry. This is the pandas operation that transforms the data, normalizes the age data. Now we need to find the normalize function within the CML library. To do that, there's you can do help CML ops, and it lists all the categories of operations we have. In this case, cleaning, restructuring, and math, which, as you can imagine, is where the normalize function is located. So we can again do help CML ops math normalize, and we see what is required to run normalize with its inputs and everything like that. So now that we've done that, and every operation is also in the root level of the library. So if you know the name, you can just go ahead and type it in, and you don't have to discover it with these long paths. So now I'm adding the normalize operation to the CS file, and I am writing it to effectively a variable called data temp, which I defined coming out of the concat function or operation, and I'm specifically overriding the age column with the new normalized data. And then I do the same thing with amount. And here you can see that we have both three operations, the concat, and then two normalized functions that write to data temp age. And if you notice, data temp is an output of concat math. So we keep doing this for other things like gender. And for categorical data, we actually use the one hot encoding operation with a list of the columns, because if this is streaming data, you might not always know what the columns are. And we're able to put those into the, put the one hot encoding into the structure. Then there's a few more normalizations that we do, and we also do polynomial combinations of features, all within CML. And then we drop all the columns that we don't need here by putting columns to keep in as one of the inputs to map to table. And we export that as a final version of the final output as data tab. And then we need to add an output. So we are adding a CML output object, which is a map. And we're taking it from the variable data tab. Then it is easy to print out your structure here. And even more easily, you can just write it to file, and I don't need that. So now we have a file that does all the transformations that we need, that matches with the pandas transformations we did in Python. Now we can drop it into our we can drop it into our Flogo environment and our Flogo app. So if you look here, I've already built the app, and the Flogo JSON that we use for that is actually in the GitHub repo. And you can see it here. So all you have to do is put the financial data.json that was output here. You can see in data JSON. It has a timestamp on it. We can put that in, and then we also include our TensorFlow model that at the moment I constructed in a different notebook. Now that I have that, I can just run the application, and we set up a REST interface that I can then send some input data, and it goes and transforms this data into an array of objects that are then put into the machine learning model, and we show that this is not fraudulent credit card data. Now, I sort of automagically wave my hands to create the app. We have a lot of helpful information on getting started with Flogo. I'm not going to go into it here, but effectively you just create the Flogo JSON using a UI, and from there you can build the application fairly simply with the documentation from flogo.io. So now let me go back to my slides. Oh yeah, let me give a quick plug to TIBCO Now, our innovation summit that's happening in September. I am involved in that. I don't think I specifically have a presentation, but I will be involved in constructing some of that and will be available for questions. Here's some resources that would be useful. So since Flogo is an open source, since Flogo and Catalyst ML are open source tools, we use a Gitter channel to communicate. So you can go to Flogo Lobby or Flogo ML and ask questions about Catalyst ML or anything I talked about today. And either I or one of the other knowledgeable open source people will address it. It might not necessarily be from me or TIBCO, but you will get your questions addressed. If you actually want to contribute, here is the Catalyst ML spec. So if you want to add an operation or something like that, you would modify this and add an operation in here. And then here we have the implementation that runs the transformation in Flogo. Again, you can add through the GitHub channel or through GitHub as needed. I have a Medium article that Medium article that runs through the demo I just did, and here's the demo repository that I have used.